Yeah, so we are going to jump into navigation. I shouldn't say jump into it because we've already dipped our toes into it. So we're going to dive more into it, go a little more in depth with navigation. This week is going to be navigation week. Okay, so it's going to be all navigation all week long. Side note for people here in the room, we always have the calendar posted or updated in the back. So if you wanted to know what's going on, there's what we got at Homer's. Sorry, it's way back there. Okay? So navigation all week, all this week. Will be a navigation formative this weekend for you to do at some point in time before Wednesday of next week. Because next week, Tuesday, we don't have class. Because I should say, juniors, you have school. And everybody else, not so much. Yep. Then the following, so then next week, Wednesday, we'll start with vectors. And we'll do vectors for the rest of March, basically. And then we'll finish up with vectors the last week before spring break. And then we're going to ask you to take a test before spring break starts. So the test is going to be due on Friday the 26th of March. Okay? With that being said, too, you should have just completed the 5.3 through 5.6 test and review assignment. If you haven't done so yet with that, the 5.3 test is in 2 parts. The review assignment is a 3rd part. Make sure that those get taken care of ASAP. If you haven't taken the 5.1, 5.2 review test and test yet, because that is also in 2 parts, you are way behind because the quarter ends in approximately 2.5 weeks is the end of the quarter. And quarter grades are the grades that matter for some people. They matter for spring athletics. They matter for pop concert. They matter for clubs and activities, all that fun stuff. Okay? So eligibility is tied to your quarter grade. If you are not passing at the quarter, sorry, you're academically ineligible for all of those things. Okay? All right? So there's that going on. Make sure you get that done. We again offer part of the after-school hub every day after school up in the library. There is teachers available for you for an hour, 3:30 to 4:30 up in the library. On Mondays, it's Mrs. Hill. On Wednesdays, it's Mr. Roth. And on Thursdays, it's Mr. Kruger. I probably will jump in at some point in time on a Tuesday, but I haven't quite cleared that with the powers that be yet. Okay? Meaning my wife. I haven't cleared it with her yet. So just that. Okay? All right. So you should have picked up a purple packet, which you did at Homer's. It is on It's Learning for You. It is a 4-page printout for today. We are only going to be dealing with pages 1, 2, and 3 today, just so you are aware. We'll save the other ones for later. Here we go. Okay. So we are in the purple notes packet. We are on page number 1 of that packet. That packet, just so you are aware, that packet is good for the remainder of March. Okay, that's your March packet. Okay. So we put all of the navigation and all of the vector stuff in that one packet for you. Okay. So navigation is a little bit different than trig. We're going to use a lot of the trig concepts, law of sines, law of cosines, some of the angles in a triangle is 180 degrees, sines, cosines, all that fun stuff. We're going to use a lot of those trig functions, but the angles from the start are in a little goofiness. Okay? And the reason that they're goofy is because all bearing and heading angles, or I should say all bearing angles, or no, I got lie. All headings. Oh, hey now. All headings are off of compass rose. And compass rose has north being 0 degrees. So straight up top is north, that is 0 degrees. Okay? So if you have a heading of 0 degrees, you're going straight north. Okay? Then the funkiness is that angles are drawn clockwise. Okay? So that means that east, which is straight out to the right, that is 90 degrees. South, which is straight down, is 180 degrees. And west, which is straight to the left, is 270 degrees. So we go that way around the circle. It's going to mess with your trigonometric unit circle brain. Because unit circle 0 starts straight out to the right and goes counterclockwise around. Compass rose starts 0 up top and goes clockwise around. Okay? But once you get through that wall, once you write down the problem, whatever it is you need to go figure out what the actual angles are, then we're back to normal. Okay? It's just a matter of finding where those angles are. So for instance, we have two of them here. We have 53 degrees and 195 degrees. If I were to draw out these two angles, I guess it's not. All right, that's fine. We'll go this way then. If I were to draw out these two angles, I would say that 53 degrees, so I've got 0 here, and then 53 degrees would be right there. So in here, then, the quote-unquote trig angle that we would use would be this angle right there. That would be our trigonometric angle, or our math angle, if you will. And that would be 37 degrees. We would also have a reference angle, because we have that in our toolbox too, which would also be 37 degrees. Okay? Now, if I go over to 195 degrees, I would start up at 0, and I would have to go 195 degrees. Well, there's 90, there's 180, and so I would be down here at 195 degrees. My trig angle would be 90, 180 plus that. So there's 15 there. So 270 minus 15 would be 260, 255. Right? My reference angle is going to be this angle here, which is 75 degrees. Okay? Confusion, bless you. Confusion is abounding in these because we've got so many different angles that we have to know and have to use. Okay? But they all mean the exact same thing. Okay? So we're going to jump around just a tad here. And so what I would like you to do now is I would like you to jump to, I believe this is on page 3 for you. Yes. Okay. Sorry for jumping around. We printed it out in the wrong order. Clearly, I don't blame myself because I wasn't the one that was printing it. Okay. So bearing and heading angles, okay, are also of the form north or south, then some angle. Okay, so there'll be some angle in there. And then east or west. Oops, I shouldn't spell it out there. I should just put the double. Okay. So north, if your angle, you got to look at what your angle is doing. So if your angle is angling up in some fashion, you would start with an N. If your angle is angling down in some fashion, you would start with an S. Then this angle here is going to be not the reference angle, but the angle off of the vertical. Okay. So that is the angle that comes off of the vertical. Reference angles, remember, come off of the horizontal. Okay? And then east or west is going to tell you if it's going to the right or to the left. If it's going to the left, that's west. If it's going to the right, that's east. Okay? All right? Let's try a couple of those. I gotta switch to this page now. Okay? So south, 35 degrees east. So that tells me that we are going down. So I'm going to start on the bottom half, 35 degrees to the east. So I'm going to go over here. And this angle right here is going to be 35 degrees. Okay? North, 80 degrees west. North would be up. West would be east. Or west would be east. And that makes sense. West would be left. 80 degrees coming off of the vertical puts me here. North 55 degrees east would put me over here, with that being a 55 degree angle there. Agree? Fantastic. What I would like you to do now is, with those three angles, fill out or find the compass rose, the bearing, excuse me, those are bearing, the heading. Okay, so find the heading of those. Okay. Then also find me the unit circle angle for those, the math angle, if you will, and the reference angle for all of those. Okay, so you're basically going to fill out the bottom half of page number trace. So I'll do my compass rose in red. Okay. So that would start here and come down to there. So that would be 180 minus 35, which would be 145. Agree with that one? Okay. Would start here and come all the way around. So that would be 360 minus 80, or 270 plus 10. 280 degrees there. This one, let's start there and go to there, and it would be the same. Agree? Yeah. Next one we asked you to find was the unit circle angle. I'll do that one in green. The unit circle angle would start at there and go all the way around there. So this one would have a unit circle angle of 270 plus 35, which would be 305 degrees. This one would start here and go around to there, so it'd be 90 plus 80. It would have a unit circle angle of 170 degrees. And last one here would start here and go to there, so that would be 5 gets me to 60, 30 more gets me to 90. So I would say 35 degrees. Agree? Yeah. Then the second or the last one said, find the reference angle for those. I'll do that in the purple. Okay. So the reference angle would be here, and that would be 55 degrees for that one. So I didn't write those in at all. So that one would be 55 degrees as my reference angle. This would be my reference angle here. That would be a 10-degree reference angle. And this one over here would be my trig angle because it's a quadrant 1 angle. So my reference angle would be 35 degrees there. But I should draw that up here and say that it is also that angle right there. So those are the 4 different ways to label one single solitary bearing or head. Okay? So what I would like you to do now is I would like you to jump back to page number 1. And I would like you to now give me, so draw those 2 bearings, or headings, I should say. Give me the trig angle give me the reference angle, and give me the bearing angle. So the north, whatever, whichever one. Okay? North, south, angle, east, west. For both of those. So 300. So if I start at 0, 90, 180, 270, 300 puts me right there. Yeah? So there's the draw. My trig angle is going to be that angle there, which is going to be 150 degrees. My reference angle is going to be right there, and that is going to be 30 degrees. Okay. So if that's 30 degrees here, then this part in here is 60 degrees, which means then that I am going north because I'm going up 60 degrees to the west because I'm going to the left. I'm going up and left. Agree? 127 degrees would be down in this general area here. My trig angle would come all the way around to there. So that gives me this angle here is 37 degrees. Because 127 minus 90 is 37. So 360 minus 37 would be 323. My reference angle then would be 37 degrees. If my reference angle is 37 degrees, then 3 gets me to 40, 53 gets me to 90. So it would be south 53 degrees east. Questions, comments, concerns, clarifications, either from here or out in the interwebs. Good? Love it. Let's put it to work now. We are going to be doing a lot of word problems the rest of the week, okay? Because we're going to be putting these into application type things. Okay? So a speedboat travels at a speed of 40 knots. Now, a knot, okay, is not just something that you tie your shoelaces into. Okay? A knot is a nautical mile per hour. Okay? A nautical mile, I'll jump in over there. A nautical mile is based on the circumference of planet Earth. Okay? So if you were to cut the Earth in half at the equator, and pick up one of the halves and look at it as a circle. So we're basically, we take this, the equator, and the equator is your circle. Okay? You would divide that into 360 degrees. So 1 degree of that gets divided into 60 minutes. So now we're at 1/60th of 1/360th of the unit circle. Okay? And so 1 minute of arc on the equator is 1 nautical mile. Okay? It's used because then it's a standard measurement, either if you're in English or in metric. Okay? So it's a standard worldwide measurement. Okay? So a knot is 1 nautical mile per hour. Okay? So a nautical mile is 1852 meters. Okay? So a nautical mile is approximately 6,076 feet. So it's a little bit longer than a regular mile. Okay? So that is what a nautical mile is and what a knot is. Okay? So a speedboat is traveling at a speed of 40 knots from Fort Lauderdale on a course of 65 degrees for 2 hours. Then it changes to a course of 155 degrees for 4 hours. We're going to assume that it's traveling at the exact same speed, okay, at 40 knots. Okay? Determine the distance and bearing. Now this is actually key right here. That is key. The distance and bearing from Fort Lauderdale to the boat. Okay, to the current position of the boat. Let's say they ran out of gas. Okay? You as the Coast Guard have to go get them. Okay? So you have to do that. Right? So what I want you to do now is I want you to attempt, and the key word there is attempt, to just draw this picture. Draw this triangle. That's all I want you to do right now, is to draw this triangle, to see if you can figure out where that boat is. Okay? I do like the fact that I saw most of you starting out with the crosshairs on Fort Lauderdale, or roughly just right outside of Fort Lauderdale, so that you weren't on the boat. Okay? All right? So there we go. So a speedboat travels at a course of 65 degrees. So this is shooting off like that, correct? With this angle here, let me make mine a little bit bigger. With this angle here being what? What's that angle? That's 65 degrees. Okay? How long is that black side? You don't need a calculator for this. It's 80 nautical miles, right? Because if it's traveling at 40 nautical miles per hour for 2 hours, it went 80 nautical miles. Right? Then it's got a course change. So you would reset with the crosshairs there. You would reset, and it would change to 155. Now, this angle here is 155 degrees. And it went for 4 hours. So how long is that next side? $160. Agree? Okay. We need to find, I will put it in red. We need to find that red side. Let's call it X. What is, now this is the $20,000 question, used to be a game show. What is that blue angle's measure? Okay. 100 degrees? Does anybody else agree with 100 degrees? Not a lot of people supporting you. I don't either. Okay. What?
90 degrees.
90? Okay. Anybody agree with 90? I don't know if anybody knows. So we're going with either 90 or 100. Okay, let's figure it out. So if this puke orange, whatever color you want to call that, okay, is 65 there, then this angle up here is also 65 right there, right? Because of alternate interior angles. I know, I just dropped a mean old geometry on you. Okay? If this purple angle there is 155 degrees, well, I'm running out of colors. Green I got yet. Then this angle here is 25? 5 gets me, yep. So altogether, those two make 90. So that's a 90-degree angle. Oh, that helps us out a lot, because what kind of a triangle do we have now? We got a right triangle. Right triangles. Okay? So how would I go about finding X? One way to find X. I don't care which way. Pythagorean theorem. Love it. Okay? We can do Pythagorean theorem on it. So is X the hypotenuse? Yeah. So we're going to have X squared is equal to 80 squared plus 160 squared. And, oh, 80 squared, turn on, 80 squared plus 160 squared gets me 32,000. Is X squared. So X is going to be, it's not going to necessarily be plus or minus, right? Because I can't have a negative distance. So we would have the square root of that. Gets me, I get here that X is 178, we'll call it 0.9. Actually, no, because I'm writing it. 0.8854, okay, but we'll call it really 179, right? Or 178.9. Okay. So X, so we are 178.9 nautical miles, and the symbol for nautical miles is NM. Okay. NM is the symbol. Really, technically, it's lowercase. I should make it look proper. So the boat is that far away. We also were tasked with finding the bearing from Fort Lauderdale. So I am going to need to find this angle right there. How would I go about finding said angle? What do we got for said angle? How would we find it? Remember, we have what kind of a triangle? A right triangle. We know all three sides. So how would we go about finding it? What? But we have a right triangle, so do I need, we could, don't get me wrong, we could use law of cosines. But do I need to use law of cosines? No. Oh, I thought you had your hand up. Oh, okay. You want a second guess? SOHCAHTOA? Yeah. Which one do you want to use? So, ha, or toa? Why would we choose toa here? Because we rounded the hypotenuse, and toa is the only one that doesn't use the hypotenuse. Yep. So I would use tangent here. Let's call this angle F. That's for Fort Lauderdale. Okay. So angle, or the tangent of angle F is going to equal the opposite side, 160, over the adjacent side, 80. So F, angle F, is going to equal the inverse tangent of 2. I get 63.434 degrees. So the boat from Fort Lauderdale is 178.9 miles on a bearing of what? What's my bearing to the boat from Fort Lauderdale? Why is it 128.4 degrees? I got to go from 0 degrees. Oops, I already used purple in that one, so we'll use black. So I got to start up here at 0, and I got to go all the way down to this red one. So I got to go through the original 65, then I got to go through the red 63.4 to get to the true bearing. So the bearing is 128.4. Right? All right? I want you to now try this one. at north and south. A boat is due west of the shoreline. The bearings of the boat from kicker. Whoa. Double tap. From 2 points 300 feet apart on the shore are 240 and 260 degrees. How far is the boat from the shore? Well, first off, so we've got 2 points on shore. Right? From those points, and agree? Okay. We just got to figure out which one is which. Which one is 240 and which one is 260. Okay. Which angle, purple or green, has a bigger bearing? Green has a bigger bearing? Okay. Because this angle down in here, switch in. This angle in here appears to be bigger than this angle there. I would agree with that. So that means that this one down here is the 260 degree bearing, which means that this in here is an 80 degree angle. Also means that this one up here is the 240 degree bearing, which means that this is the 60 degree angle there. We also know that this distance here is 300 feet. We need to find how far the boat is from shore, but we're also going to have to find that length too. Okay? Try it. Try it based off of that. So what I did is I broke out my two triangles. Okay? And so I got those two there. I know that I've got that purple angle at 60 degrees. So if I go the tangent of 60 degrees is equal to the opposite side x over the adjacent side y plus 300, I can solve that for x. If I go to the other triangle, and I know I have an 80-degree angle, I can also go the tangent of 80 is the opposite side over the adjacent side. And I can solve that for x. Since they are both solved for x, what can we do? we can set them equal to each other. If I distribute this tangent of 60 degrees, I get that. If I subtract y tangent of 60 degrees, I get that. Because I got to have my y's on the same side. If I factor a y out, I get that. If I divide I get that. That we can figure out. 3 hundo tangent of 60 divided by the tangent of 80. Make sure you're closing parentheses. Minus the tangent of 60. And I get yep. I get 131.9078. Yes? Now be careful how you're typing it in. This needs to go in its own set of parentheses when you're typing it in. You can't just do 300 tangent of 60 divided by tangent 80 minus tangent of 60, because it will only divide by tangent of 80 degrees. Then it'll subtract off the tangent of 60. Okay? But that's why we need to find x. So I'm going to go back to y tangent of 80 degrees is equal to x. And my y value is now 131.9078. And I'm going to multiply that by the tangent of 80 degrees. And that's going to give me x. So I'm leaving it on my calculator. I just hit times tangent of 80. And I get that this vote is 748. feet offshore. Yes? Whew! Okay. Questions, comments, concerns, clarifications? Need me to show you how to do it on your calculator? All good in said hood. Tomorrow we'll be doing more word problems. Thursday we'll be doing more word problems. Friday we'll be doing more word problems. Okay? It's all word problems from here on out. Okay? Until we get into vectors.